Look at your hand. Look at the walls around you, the air you breathe, the distant stars. Everything you have ever touched, seen, or known is made of the same basic ingredients: protons and neutrons, tightly packed bundles of energy that form the atoms of our world. In our daily lives, we perceive this as the final, permanent state of matter. We are told that atoms are the solid foundations of reality, but theoretical physics suggests a terrifying alternative. What if our version of matter is not the most stable state? What if there is a configuration of existence so dense, so perfect, that our entire observable universe is actually in a state of fragile tension? This is the study of strange matter, the most dangerous substance allowed by the laws of physics. To understand the nature of this threat, we must observe the subatomic world, beyond the atom, beyond the nucleus. Inside every proton and neutron are even smaller particles called quarks. In our world, there are primarily two types: up quarks and down quarks. They exist in perfect three-part harmony, held together by the strong nuclear force. This is the matter that builds our mountains, our oceans, and our bodies. It is the matter of the age of light. But there is a place in the cosmos where the rules of the neighborhood are crushed: the heart of a neutron star. A neutron star is the city-sized corpse of a giant sun. The pressure here is so extreme that the very structure of the atom is pulverized. Electrons are forced into protons. Matter is compressed to a density that defies human logic. In the absolute core of these dead stars, the pressure reaches a critical tipping point. The boundaries between individual protons and neutrons dissolve. The up and down quarks are squeezed together into a chaotic, liquid soup. And then, according to the laws of thermodynamics, a transformation occurs. Under this impossible weight, some of the down quarks begin to shift. They change their identity. They become a third type, the strange quark. When this happens, a new substance is born: strange matter. On a mathematical level, strange matter is a masterpiece of efficiency. It is the most stable state of matter theoretically possible. It is denser than a standard neutron star. It is stronger than any metal. It is perfectly uniform and indestructible. If a neutron star contains enough of this substance, it stops being a standard remnant and becomes a strange star, a solid, perfect sphere of subatomic stability. Before we dive deeper into the clinical reality of this cosmic contagion, please consider supporting our mission. If you find value in these high-fidelity windows into the universe, like this video and subscribe to Sideral Space. Your support allows us to continue these deep dives into the cosmos. Let us return to the infection. The perfection of strange matter carries a terrifying characteristic. Because it is more stable than normal matter, it acts as a cosmic magnet for energy. It follows the fundamental law of entropy. Everything in the material world moves toward the lowest, most stable energy state. In the eyes of the cold equations of physics, our normal matter is a high-energy, less efficient configuration. Strange matter is the ultimate solution. This leads to the hypothesis of the strangelet. Imagine a microscopic fragment of strange matter, a seed escaping from the high-speed collision of two strange stars. This tiny fragment, no larger than a single atom, begins to drift through the void of space. It is invisible, it is cold, and it is perfectly patient. If a strangelet were to enter our solar system, there would be no warning. It would not collide with the Earth like a traditional asteroid. It would simply sink. Because of its extreme density, the strangelet would pass through our atmosphere and the Earth's crust as if they were ghosts. Gravity would pull it until it settled in the very center of our planet's core. And then the rewrite begins. The moment the strangelet touches a normal atom, the local laws of chemistry fail. The protons and neutrons of the Earth's iron core would touch the strangelet and instantly dissolve into quarks. Those quarks would then be converted into strange matter to match the seed. It is a subatomic chain reaction, a contagion that spreads at the speed of touch. Every atom it converts becomes a new part of the seed. The core of the Earth would begin to turn into a hot, dense liquid of strange quarks. The process moves outward, consuming everything in its path, from the inside out. The planet would begin to shrink. As the atoms lose their structure and the empty space between them vanishes, the Earth would collapse in on itself. This is not a collapse through gravity, but a total rewrite of its material identity. In a matter of hours, the Earth would no longer be a world of oceans, continents, and life. It would be a sphere of strange matter, only 10 kilometers wide, a city-sized ball of hyperdense subatomic soup, glowing with the immense heat of the conversion. Everything we were, every mountain, every monument, every memory, would be compressed into a single, uniform substance. We would not be destroyed in the traditional sense. We would be incorporated into a more stable version of physical reality. The most unsettling part of this theory is its clinical possibility. If strange matter is the true ground state of the universe, then space is a minefield. There could be quadrillions of these microscopic seeds drifting between the stars right now. Some astronomers have even proposed that dark matter, the invisible mass that holds our galaxy together, might actually be vast clouds of strangelets. If this is true, it presents a profound paradox. The very substance that allows our galaxy to maintain its structure could be the same substance that would delete us if we ever crossed its path. We live in a world of up and down quarks. We live in a brief, exceptional moment of fragile chemistry and complex atoms. In the vast timeline of the cosmos, we are a temporary configuration of energy. We are lucky that the distances between the stars are so vast. We are lucky that the remnants of dead suns are far away. For now, our chemistry holds. Our atoms remain spherical. Our identity remains our own. But the seeds of the strange are out there, indestructible, perfect, waiting to show the universe its final form. If the transformation of matter is the ultimate end of a world, what happens when a star refuses to die at all? What happens when the laws of time and light are bent by an object that seems to defy the very vacuum of space? We have much more to explore. To support our mission, please like this video and subscribe to Sideral Space. Your support allows us to continue creating these deep dives into the cosmos. Thank you for watching. Click here to return to the Magnetar, or click here to witness the final silence of the heat death.